ISPRA, Euratom's Common Research Center. The construction of the ESSOR reactor started at the ISPRA Center in June 1963. Under the supervision of a team of Euratom technicians from the Orgel project, a group of firms including Groupement Atomique Alsacien Atlantique of France, Interatom of Germany, and Montecatini Edison of Italy were commissioned as industrial architects for the construction of the reactor. The coordination of the various construction stages, to which more than 100 firms in the 6 community countries contributed, was done by means of the PERT method. PERT standing for Program Evaluation and Review Technique. PERT involves making ample use of computers. One of the first cases of PERT being used in Europe was for the construction of ESSOR. This method made it possible for those in charge of reactor construction to explore in detail the intricate labyrinth of the many construction steps involved when progressively passing from design conception to material achievement. Thousands of tons of iron, thousands of cubic meters of heavy concrete, for shielding purposes, surround the space housing the reactor core. In March 1957, the Rome Treaty established the European Atomic Energy Community, also known as Euratom. Early in 1958, Euratom set to work along the assigned lines and soon started to develop a heavy water-moderated, organic-cooled power reactor type which received the name of Orgel. As part of the Orgel program, in October 1962, the Euratom Commission decided to build the ESSOR reactor, which was mainly intended to test full-scale fuel and channels for the Orgel concept, but, should the need arise, would also be able to serve for the development of other heavy water-moderated reactor systems. The reactor core will comprise an experimental zone surrounded by a ring of highly enriched uranium fuel elements, called feeding zone. The feeding zone is responsible for the criticality of the composite core. The experimental zone will be equipped with up to 12 channels, the design of which can be adapted to specific requirements. The beams of the revolving crane bridge are arriving from France. The 50-ton bridge will be installed inside the containment building, which encloses the core and the primary circuit. The crane bridge turns while resting on a circular girder. Buildings around the steel containment are being built to house the main control room, the electric power feed, the general purpose equipment, and 2 high-activity laboratories for irradiated fuel and channel components. The containment building is equipped with 2 airlocks for the personnel, and also with a proofing door for large-sized equipment. The structure resting on the crane bridge is a temporary support for the assembly of the dome section. The dome and the cylindrical wall of the containment building are connected by means of a reinforcement ring. The dome is internally reinforced with ribs. We are now in the spring of 1965. The weldings are being controlled. The containment building has a 45-meter diameter with a similar height. Its base lies 11 meters below the ground level. The transformers supplying electric power to the reactor plant are being installed. May 1965. The large containment building is being pressurized in order to check mechanical strength and proofing. Due heed is paid to to changes in temperature and pressure. Extensometers have been placed in the structure's critical points. All relevant data arrive at the equipment installed inside this room. Proofing is being checked even more thoroughly, making use of soap and water. This method, though apparently rudimentary, is extremely effective. In every circumstance, the containment building will keep the internal atmosphere from communicating in an uncontrolled manner with the air outside. Close to the main building stands the auxiliary diesel powerhouse, intended to trip on automatically in case of any interruption in the power supply. The large crane used for construction has now completed its task. 65 meters high, this mantling is underway. Quite an acrobatic job. Finishing touches are being given to the containment building. It has been painted and is now being coated with an insulating layer of glass fiber, which is in turn protected by corrugated metal sheets. Heavy construction work is almost completed. The reactor surroundings are being made more orderly. The inside aspect of the building is also changing. Ironically, it looks like an empty mine ready to be filled. We are in the center of the containment building. The reactor core will be installed in the pit. Its housing is being made ready. The noise of metal being plied recalls a mechanical workshop. Henceforth, workers have to grapple with the dust. White outfits are appearing on the site. This is to ensure strict cleanliness when carrying out very delicate mechanical work. White outfits also here at Saint-Nazaire on the French Atlantic coast. The workshops of the Chantier de l'Atlantique build a stainless steel vessel to enclose the reactor core. They build also both upper and lower shutdown axial shields. The latter also supports the core vessel. The experimental channels and control rods will pass through the holes in the shutdown shields. Meanwhile, at Ypres, the radio shield is being installed. In turn, the vessel will be installed inside this shield. The purpose of the radio shield is to reduce the radiation level and heat flow through the concrete, which ensures biological shielding around the core. A chimney is being built here to expel air coming from the interior of the containment building. November 1965. The core vessel arrives at the site and is about to be fastened to the lower shutdown shield. It is being lowered gingerly in its final position. Its total height, shutdown shields included, is about 5.50 meters, and its mean diameter is 2.20 meters. Of the two independent heavy water circuits, one will cool the feeding zone and the other the heavy water moderator. The cooling pumps of the feeding zone are now being installed. Still more empty space. This and other such vaults will house the experimental circuits. In the cooling down pool, the equipment used for transporting irradiated fuel elements is being checked. The pool is connected on one side with the containment building and on the other with hot laboratories. In the core's feeding zone, there will be 16 enriched uranium fuel elements arranged in a ring around the experimental channel. Next to the feeding zone and outwards are the control rods. In Duisburg, Germany, loading and unloading machines for fuel elements are being constructed. They are equipped with shields and a nitrogen cooling system for handling and transporting active components. chimney construction has been completed. Air inside the reactor will first be monitored and filtered. It will then be released through the 80-meter-high chimney. Several of the experimental channels are connected to organic liquid cooling circuits, as required by the Orgel program. One experimental channel has been made available for the Italian Cireni program, which is intended to develop a heavy water-moderated, boiling light water-cooled reactor type. In these vaults, the organic liquid cooling circuits are beginning to take shape. This equipment will control temperature, pressure, and composition of the cooling liquid in the experimental zone. The construction of the boiling light water circuit is also to begin soon. Both heavy water circuits cooling the moderator and feeding zones are now ready for test. The main parts of these circuits are installed in thick-walled vaults and are thus shielded when the reactor is operating at full power. After completion of the mechanical test during circuit assembly, leak tests are performed with a helium mass spectrometer. The control instrumentation required during operation for the reactor and its auxiliary equipment is grouped in the main control room located outside the containment building. The control rods are now being installed. There are 12 control rods and 4 safety rods. Components intended to be introduced in the core, in particular the experimental fuel elements, the channel parts, and the feeding fuel elements, are all being prepared in this laboratory. Autumn 1966. A provisional control room has been installed for testing the heavy water circuit.
On baisse quand même un peu, hein.
28 tons of heavy water are being introduced in the cooling circuit of the feeding and moderator zone. physical chemistry laboratory has been set up next to the reactor for heavy water purity control. Spring 1967. The first fuel elements are now inside the reactor for criticality tests at zero power. By means of these control panels, the reaction conditions are being kept under control. On March 19, 1967, at 10:32 p.m., a chain reaction is being established for the first time. ESSOR becomes critical. Criticality tests have confirmed the neutron calculations and safety evaluations. But the work must still be completed. The last adjustments of the TEAS system, data handling and watching system, are being made. The system handles most of the data collected on the various ESSOR circuits. It compares the measured values with preset operation levels, and according to pre-established rules, sets off alarms or provides for safety actions as the case may be. Acceptance tests are being carried out in the auxiliary control room and in the vaults of the experimental circuits. Men have converted a quiet corner of earth into a kind of enchanted castle, inhabited by the people likely to share our future. These men are checking the behavior of the circulatory system of their creature, whose heart is beginning to beat. The mock-up we are observing here, near the heavy water circuits, makes it possible to understand better the general reactor arrangement. These are the vaults of the experimental circuits. Loading and unloading machines are being tested.
Ja, Sie sind fertig.
The fuel elements extracted from the core lie for a decay period in this pool before being introduced into the hot laboratory. This Ecole laboratory, Ecole standing for Fuel Element Workshop, is equipped with a view to examine and dismantle fuel elements. as well as to carry out various tests on the most delicate parts of the dismantled fuel. Likewise, the pressure tubes and other channel components will be examined and tested in another hot laboratory. The ATFI laboratory, ATFI standing for Irradiated Pressure Tube Workshop, which is equipped for handling the large-sized channel components and other active parts such as control and regulation rods. In this laboratory, the channel components are being cut to just the right size for testing purposes and trimmed so that they can be evacuated outside the reactor. In today's Europe, the ESSOR reactor represents a powerful tool for solving the problems connected with the development of heavy water power reactors. The industrial development of our time continuously calls for new energy resources. Man, when playing the game of progress, should spare no effort to avoid the penalty for persistently constraining nature's laws such a long way off their original course.